morning, Algebros. Today we're going to compare our arithmetic and geometric series. So remember, a sequence is a set of terms written in a given order. So when we look at the function on the right, okay, our first term is 0, 1, 2, 3, and we're just going to continue that nice linear system. Okay, and it looks like we're plus 5, plus 5, plus 5. So my next two boxes would be 20 and 25. So this is an arithmetic sequence. We talked about those previously. Okay, our arithmetic sequence has common differences. Okay. Okay, so we've got those common numbers. So rate of change. What is rate of change? Remember, rate of change is just a fancy way to say slope. And that is a common term. And really, our function is increasing by that common number, and that is just slope. So for this equation on the right, we want to know, we're going to write it in y equals mx plus b. Okay. So our y-intercept is our b, so where does that start? We're going to put a 0, and then our slope, what is it increasing by? For every one it goes right, it goes up 5. So 5x. So we can just leave this as y equals 5x because we don't have to write that 0 in math. And if we wanted to turn around and solve for function of 25, we'd say f of 25 equals 5 times x. And our x, we're going to substitute that 25. So 5 times 25. You got 5 quarters in your pocket. You've got $1.25. The function on the right, again, we're going to go up one number each time. So 4, 5. But now we're going up by our common ratio. Okay, our common ratio, it looks like we're multiplying each number by 4. So common ratio or a common factor. You could also see it called a common factor. Okay, so if we were multiplying 256 times 4, we'd get up to 1024. And like you guys all like to play on your Chromebooks, our next number would be 4096. So this is an exponential function, okay? Because we have that common ratio, that common factor. So a ratio here, remember, it's y equals a times b to the x. So it would be our first number, 4 times 4 to the x power. So if we wanted to find the function of 8, so f of 8 equals 4 times 4 to the 8th power. Our number would be 262,144. So exponential series go a little bit higher, a lot quicker. So the first thing we're going to do is we're going to identify our terms. Did I skip a page? I sure did. So arithmetic sequences will have a common difference. Get back to the top. So they will have a common difference. Whereas our exponential function will have a common ratio or common factor. So with our arithmetic sequence, we're adding and subtracting. And our geometric sequence, we are multiplying. So we look at our sequence, we got to determine whether it's geometric, arithmetic, or neither. Then we want to identify our common difference or common ratio. So it looks like we go 5 to 10 is plus 5. or maybe it's times 2, but the next one looks like it's plus 5, plus 5, plus 5. So this is an arithmetic sequence that has a common difference of positive 5, and it is a linear function. Number 2, 64 to 32. They could be subtracting 32, or they're multiplying by 1/2. When we look at the next one, it would be subtracting 16. So that's not a common ratio, but it still meets our multiplying by 1/2 standard. Okay. So this would be a geometric series with a common ratio of 1/2, making it an exponential function. Number 10, looks like we went plus 20, but that's plus 60. So it's not arithmetic because we would need a common number there. But if we look at it geometrically, 10 to 30 is times 3, 30 to 90 times 3, 90 to 270 times 3, 270 to 810 is times 3. So again, this would be geometric with a common ratio of multiplied by 3, making it an exponential function. And then our final one, 1 to 4 is plus 3, 4 to 9 is plus 5, 9 to 16 is plus 7, 16 to 25 plus 9. So it's not really arithmetic because we don't have a common jump. Okay, what if I check arithmetically? To get from 1 to 4, we'd have to times 4. Well, 4 to 9 isn't even going to give me anything close. 9 to 16 is the same way. So this would be an example of neither sequence. Okay, our sequential notation is going to use subscript notation. That's that a to the n number we talked about with arithmetic sequences. So we're going to identify each number in the sequence using that a to the n, kind of the same way that in function notation we use f to the n, so we could substitute x in. Okay, so this would be function notation, f to n. The function of x is another way you could hear it. Function of x. And subscript notation would be a to the, so this would be our nth term. Okay, that's our unknown number. So for this one, so we're going to substitute 4 into our function. So 2 times 4 plus 1. 2 times 4 is 8. And 8 plus 1 is 9. So they told us they wanted us to find y when x was 4. And that's kind of the same thing that happens in our subscript notation. They want us to find the number, the 4th number in our sequence. So A4 is 2 times 4 plus 1. 8 plus 1, 9. So when we're finding the function, that's actually our y value. And then when we're finding our nth term, it's kind of our x value. So we want to identify the terms of our sequence and then find the next 3 and describe what's happening. So we go 4 to negative 1 is minus 5. 1 to negative 6, minus 5. Negative 6 to negative 11 is minus 5. So the next 3 terms, so we could say a to the n is our first number minus 1. So our next 3 terms would be, if we keep subtracting, negative 16, negative 21, and negative 26. And because this has a common difference, this is an arithmetic sequence. Over here, 3 to negative 1, they multiplied by 1/3. Negative 1 to 1/3, multiply by negative 1/3. 1/3 to negative 1/9, multiply by negative 1/3. So our next three terms, we were negative, now we're going to be positive. So positive 1/27, negative 1/81st, and then 81 times 3 is going to give us negative 241 and one, or positive, excuse me, 1/243. Because we have a common ratio, this is a geometric sequence. So what we've done today is we've talked about our arithmetic versus geometric, which is really just linear versus exponential. Linear uses that point slope formula, I mean not point slope, but slope intercept, y equals mx plus b. And exponential, we get ab plus x. You guys got the back sheet for homework. We'll see y'all tomorrow.